Okay, here are your solutions to guided practice 1-7. Our first problem is 2 6/10 times 10 to the 5th times the quantity 1.9 times 10 to the 2nd power. We can take this 10 to the 5th and 10 to the 2nd power. That becomes 10 to the 7th. Then all we have to do is multiply 2.6 times 1.9. And we multiply 2.6 times 1.9. We get 4 94/100ths times the 10 to the 7th. And since we have only a single digit out front, we're complete there. Number 2, we have the quantity 8 37/100ths times 10 to the 8th divided by the quantity 2.7 times 10 to the 3rd. We can simplify the 10 to the 8th divided by the 10 to the 3rd and immediately get 10 to the 5th. Then all we have to do is do 8 37/100ths divided by 2 7/10. Do that in the calculator and we get 3 1/10 and then times 10 to the 5th. Again, we have a single digit, so we're complete. Problem number 3 is about text messages, something that you can all relate to. In the year 2005, there were 8.1 times 10 to the 10th text messages sent. In 2010, that number jumped up considerably to 1,810,000,000,000, which looks like this. So we need to count from here to here to put this in scientific notation, so it's easy. It's 3, 6, 9, 12 places we moved. So we have 1.8 times 10 to the 12th is how we would write this number in scientific notation. The question is, how many times more text messages were sent in 2010 than 2005? So we're going to take the quantity in 2010 right here and divide it by the quantity in 2005. We divide because that's what we do when we're looking at how many times more. If you say you had a 10-pound barbell and a 2-pound barbell, how would you figure out how many times more? 10 divided by 2. Always use a simpler problem if you need to in order to figure out your process, because this is the key to this problem, is knowing that it's a division problem in spite of the fact that they say times in the question. That's a big problem for lots of students. So we have two things. We have 10 to the 12th divided by 10 to the 10th, which is 10 squared. That's the easy part. And then we have 1.8 divided by 8.1. So I broke it into the two pieces here. We have 1 8/10 divided by 8 1/10. Put that in a calculator, you get 0.2 repeating, and that's times 10 squared. But in this case, they're asking you how many times more. You don't want to answer a question like that necessarily with scientific notation, and this would be wrong anyway. We would put this as 2.2 times 10 to the 1st. But they just ask you how many times more. And once again, the book does the crazy thing and rounds the answer and says that in 2010 there were about 20 times as many text messages in 2005. Really fast growth. Number 4, 8 9/10 times 10 to the 9th plus the quantity 4 2/10 times 10 to the 6th. Now, back to that thing that we've been looking at. Which should I switch? Should I get this to 10 to the 6th or should I get this to 10 to the 9th? Well, if I move this to 10 to the 9th, we're going to have a fairly small number added to our what is already 8. So I think that's obviously the best way to go. That's what you want to do when you're looking at these, is look at which one you can switch and still end up with two numbers that you're either going to add and or subtract and still end up with a single digit out front. So now we have 10 to the 9th here and here, so it's multiplied by 10 to the 9th. And we are adding these numbers, 8.9, 8 9/10 plus 0.0042. Add that up and you get 8.9042 times 10 to the 9th power. Number 5, 9 64/100ths times 10 to the 8th power minus the quantity 5 29/100ths times 10 to the 6th power. Again, which should we switch? Well, obviously, if we switch this to the 8th power, we're subtracting a very small number here. We're still going to end up just fine here, so that's the way to go. We have to. The way to do this real easily is I would just write a few zeros, 5, 2, 9, and then say, okay, I'm going from 10 to the 8th, 10 to the 6th. I have to move it 2 places. It was there. I'm going to move it to 1, 2. It's going to be right here. So it's 0.529. So it's 0.0529 times 10 to the 8th. We're going to have 10 to the 8th for our common power, so we're going to multiply by 10 to the 8th, and we're going to go 9 64/100ths. That is a 9 there yet. Just rubbed it with my hand. 9 64/100ths minus 0.0529. And we get 9.5871 times 10 to the 8th power. Number 6, the quantity 1/35/100 times 10 to the 6th minus 117,000. Now in this case here, I put the intermediate step here, but what I would, because this is what most kids would do, because you're going to move the decimal point to right there all the time, right? But in this case, you know that you need the 10 to the 6th power here, because that's what we have here, and you're going to change this, so why not change that one to 10 to the 6th at the very same time? So what I would do is I would just write my digits here, and if I'm going to multiply it by 10 to the 6th, I need to move it 3, 6. That means I'm going to have 0.117 times 10 to the 6th. We can jump right to this step. Always just write it in there what you're going to do. So we have 1.35 times 10 to the 6th minus 0.117 times 10 to the 6th. So our common here is 10 to the 6th, and we have 1/35/100 minus 117/1000ths, and we get 1.233 times 10 to the 6th for our final answer. Number 7, we have 5,400 plus 6.8 times 10 to the 5th. Same thing here. We know that we're going to need 10 to the 5th, so let's change this to 10 to the 5th right away. So if we move it 1, 2, 3, 4, 5, we would have a 0 out front. So we have 0.054 times 10 to the 5th plus 6.8 times 10 to the 5th. So we're going to take 0.054 plus 6.8 and all of that times the common factor of 10 to the 5th. So we have 6 and 854/1000ths times 10 to the 5th. Number 8, your essential question. How does this make things easier? Well, if you really think about it, we're dealing with some really large numbers before, when we had the 10 to the, I think it was 10th power and 10 to the 12th power with some digit out front there. We're really dealing with some really large numbers, but if you're adding, subtracting, multiplying, or dividing them, you can take all those powers of 10. We can use the known properties of products of powers, etc. We can use those properties to simplify the powers of 10, and then we're just, what's remaining is we can evaluate the remaining digits in a compact form. You know, like say 5.3 times 10 to the 14th power. That's a huge number. But we can use the powers of 10 to get rid of most of that, and now all we have to do is use numbers like 5.3 or 6.85 or whatever it is. So it does make things easier. Thank you.